Tone mapping problem: how to present HDR images on LDR monitors so as to retain real vision perception, has been there for long. A wide variety of approaches have been proposed, including human visual system-based compression, image appearance model, and other engineering methods. In the first part, we hand-carve 3 HVS-based tone mapping algorithms and try to improve them. Most operators can produce nice preliminary image, while one may prefer not only the unclouded azure sky in operator A, but also the emerald green bushes in operator B. Photographers and artists tend to use image editing software, such as the well-known Adobe Photoshop, to mix those images together. In the second part, we propose a diffusion-based image blending technique by building triangular meshes. The middle equation is used to calculate response. Starting from 2 log unit from intensity average, the contrast is gradually weakened. From 3 log unit, it's almost pure white and black. Although it matched our visual perception, it almost loses all the details too. As shown in the right figure, the blue areas are underexposed, and the red areas are overexposed. We modify the algorithm so as to recover the details in extreme parts. First, we generate a global operator image and a local operator image. Second, we threshold the overexposed and underexposed area to be the pixels intensity that is more than 3 log unit to average intensity. Third, we use a 5x5 circular kernel to dilate extreme area. Finally, using the extreme area as a mask, we blend the global operator with local operator. Here's the comparison. As you can see, the details in the extreme parts are recovered, and the contrast in middle parts are retained. As most local operator, the photographic operator also faces the trade-off between enhanced contrast and halo artifact. In macro perspective, we prefer sharp and clear image with higher epsilon. In micro perspective, we prefer less halo artifact with lower epsilon. Our approach tries to retain both of them. First, we build a 4-layer epsilon tower with 4 different values. Second, we subtract each adjacent layer to produce a 3-layer difference map. Third, we threshold halo areas to be difference exceeds more than 10% of intensity range on each difference map. Fourth, we use a 3x3 cross kernel to dilate each difference map. Here's our halo areas. Finally, from bottom to top, we use the halo areas as a mask to replace base image with higher epsilon image. Here's the comparison. We retain the sharp and clear properties in higher epsilon, and also less halo artifact in lower epsilon. Another shortcoming of local operator is that its local adaptation is computationally expensive. For adaptive gain control operator, the weights in local window are calculated by intensity difference, rather than relative position, like Gaussian filter. We provide a multi-process approach to calculate the adaptation image, but the bottleneck is the number of CPU cores as shown in the figure. In the second part, first, we let the user to fine-tune the output of tone mapping operator. We provide 2 self-designed nonlinear mapping function. Notice that the positive brightness adjustment increase brightness and contrast of dark side, while not strongly clipping the bright side as linear mapping. Also, the positive contrast adjustment increases contrast in median part, while preserving details in extreme part, vice versa. And mix both curves with a weighted sum. Here's the result. Then, we provide a method for user to fast blend multiple images together with different weight at different position. Here, we want to combine the profound starry sky in photographic operator and more detail about grassland in photoreceptor operator. First, there are 4 base anchors at the corners of image, which can't be deleted. Second, user can add, modify or delete anchor at any position with different weight of image. Third, the program executes Delaunay triangulation to generate a 2D mesh. Finally, the program traverses every triangle to do interpolation in it. Finally, since most users are not coding experts, we provide a graphical user interface for better maneuver.